Okay, so now we want to look at limiting and excess reagent. How do we do calculations involving this? But before that, let's look at this scenario. So assuming you have 14 boys and 9 girls only. Now if we are to pair them, we can say that you have 9 girls pairing with 9 boys, meaning that we will have 5 of the boys that will be left without partners. So the number of girls limits the number of boys that can dance in, let's say, a contest. We can also say that we have 5 boys in excess. So the limiting becomes the number of girls here minus this one will give us 5 boys in excess. So that is the scenario that we are going to use. Now let's start with the steps. So the first one is write a balanced equation for the reaction. In most cases, we are given the balanced equation, so we can just go with that. The second point is we have to convert the known masses of substances to moles. That is by using the formula N is equal to mass over molar mass. The next point, determine which reactant is limiting. We have to determine which reactant is limiting. So we'll look at that as we move on. The next point, using the amount of the limiting reactant and the appropriate mole ratios, compute the number of moles of the desired product. So how do we do that? So when we pick one question, you will see how it is done. So if you are being asked what is the limiting reactant, it is the one with the least number of moles or least amount of substance, and these moles are determined through mole ratio. So we are going to go through the mole ratio process to determine the limiting reactant or reagent. So now let's start with an example. This is a simple example that we want to start with. So we have a recipe for cookies states that 3 cups of flour, 2 eggs, and 1.5 tablespoons of baking soda can make 24 cookies. So let's say that you have 5 cups of flour, 3 eggs, and 4 of the baking soda. How do we write an equation for this? So let's look at what we have here. Please take note of this. We have 5 cups of flour. We are going to use that when we start the mole ratio. 3 eggs, then 4 tablespoons of baking soda. So let's see how we can write this equation. The question is saying that what is the limiting reactant? How can you tell? So with the question given, we have 3 cups of flour. So that is what we can see here. Plus 2 eggs that was stated in the question. Plus the 1.5 baking soda which was stated. And all gave us 24 cookies. So how do we compute to get the limiting reactant? Please take note of this. Whenever you want to determine the limiting, what you do is you pick the reactant, any of the reactant. In fact, we are going to work with all the reactant here. So we will pick the first reactant and write the mole ratio between the first reactant and the product. So the second reactant against product. The third one against what? Product. So through that, we can determine the limiting reactant. That is the least number of moles. So let's start. So from the question, we have N of F. The N of F means the moles of the flour over N of the cookies. Take note of this. We always determine that of the product. So it is the product against the reactant. So after determining or calculating for the number here, which is the product, what you do is you just have to determine the one which will give you the least for the product. So N of F is equal to 3 over 24. That is the flour over the cookies is equal to their respective what ratio. So 3 and 24 here. So what we do now, from the question, we're given 5 cups of flour. That is the moles of the flour, which is 5 here, is equal to the ratio given. So we determine that of the cookies. So N of CO will be equal to 5 times 24 divided by 3, and that will give us 40 cookies. We are not done. We have to write mole ratio between the second reactant here and the product, for which we have to determine that of the product. So we have N of E over N of what? The cookies. In this E, we're given the mole. So we have to replace the E here with the mole that was given in the question. And the mole that was given was 3 here. So we have 3 over N of the cookies is equal to 2 over 24. So we have the X to be 3 is equal to the ratio. So calculating for N of the cookies will give us 36 cookies. Now looking at the last one, we have 1.5 BS, that is baking soda, with 24 cookies. So that will give us the mole of the baking soda over the mole of CO, which is equal to 1.5 over 24. That is what we have over here. Now what do we do? From the question, we're given the amount of baking soda, which is 4. So that becomes 4 times 24 divided by 1.5, and that gave us 64 cookies. So looking at the 3 figures that we have here, you can easily determine the number of cookies which will give us the least. So let's see what happens next. So we have N of 40 cookies, 36 and 64. The least here is indicating that the second one, which is for the X, is the limiting reactant or the limiting reagent. So least amount of cookies product made by using the X available on hand. Egg is the limiting reactant. That is, it limits the amount of cookies that can be made. Now let's look at this question. The question says ammonia gas reacts with oxygen gas according to the following equation. So now let's look at the equation. So we have 4 moles of ammonia plus 5 moles of O2, giving us 4 moles of NO plus 6 moles of water. So this is the equation. What are we to determine? So the question says, if you had 7 moles of ammonia and 6 moles of oxygen gas, what would be the limiting reactant? So we have 7 moles for this. We have 6 moles of the oxygen. We want to determine the limiting. Please take note of this. In this reaction, we are not going to depend on the water. We are depending on NO. So we are going to write mole ratio between this reactant and the product here. Oxygen against the product. So as we did in the previous one. So let's move on. So we have N of ammonia over N of NO is equal to 4:4. That is 1:1. In the question, we're given the moles of ammonia to be 7. So 7 over N of NO is equal to 1/1, meaning that the number of moles of NO will be equal to 7. So we have determined that of ammonia. Now let's move to that of oxygen. So with the same mole ratio approach, we write. So N of O2 over N of NO. We want to determine the NO, which is the product, is equal to 5/4. So were we given the moles of oxygen? Oh yes, we're given. So the moles of oxygen was giving us 6. So when you insert that in the equation, you are going to get N of NO times 5 to be equal to 6 times 4. So when you divide, you are going to get N of NO to be equal to 4.8 moles. Now let's compare something here. We have 4.8 moles against 7 moles. So what can you say about this? Yes, your guess is right. You have determined the limiting reactant. So oxygen becomes our limiting reactant. Alright, now let's look at this third question, which involves masses. So the question reads, what mass of CO2 could be formed by the reaction of 16.0 grams of CH4 with 48.0 grams of O2? We have this reaction given to us. We are very, very fortunate to have this reaction. So what do? See, it is always the reactant against the product. Reactant against product, so that we can determine the limiting mole. Water here is not what we are interested in. So we are going to depend on CO2. So from the product here, we have to compare with CH4 to determine their moles. And that is what we are going to do. So let's look at what we can do from this. If you remember, the steps told us to convert mass to moles. So when you pick N of CH4, we're given the mass. The mass that was given in the question was 16. Now, if you calculate the molar mass of CH4, that is 12 plus 4, which is 4 times 1. That will also give us 16. So when you divide, you are getting 1 mole. Now let's convert that of the oxygen as well. We want to convert everything to moles before we use the mole ratio to solve for the limiting. So with that of oxygen, we're given a mass of 48. Molar mass of oxygen, which is 2 times 16, will give us 32. So that is what we have over here. So that is equal to 1.5 moles. So now we know the moles of CH4, we know the moles of O2. We can easily insert that in their equation. So between the product and the first reactant, which is the methane, CH4, we have N of CH4 over N of CO2 to be equal to 1:1. We are looking for CO2 because we want to know the mole of CO2. Knowing the mole of CH4, we can easily insert that here, which is 1. So if you have 1 here, the ratio is 1:1. Automatically, N of CO2 will give you 1 mole. So take note of that. Now let's write between oxygen and CO2 and see what we can also get from that. So between N of O2 and N of CO2, the ratio is 2:1. So in the question, we had the mole of O2 to be 1.5 over N of CO2, which is the product, is equal to 2/1. So when you divide, you are going to get N of CO2 to be equal to 0.75 mole. Now let's compare. In the CH4 reaction, we had 1 mole for CO2. In the reaction between oxygen and CO2, we are getting 0.75 mole. Now the question is 1 and 0.75. Which one is the least? It is the one obtained from oxygen. So therefore, O2 is the limiting reagent. The question didn't end here, so we have to continue. So what you can do is, if you want to determine the excess mole, In this question, we are not going to work with the excess, but it is very important to know this. So whenever you are given a question and you have to work with the excess, this is how you can do that. What you do is you write the reaction between the reactants. So that is CH4 against O2. Then you determine that of the excess. So from here, we realize that CH4 gave us 1 mole. So that is what we are looking for. So when you insert 1.5 here, that is the figure obtained. 1.5 2 times CH4, and that will give us N of CH4 to be equal to 0.5 mole. So we have 0.5 mole in excess. But for this particular question, we are not going to work with this. But in case we are to work with the excess mole, we can depend on what we have done here. Now let's continue with our approach. So if you want to determine the mass of CO2 which could be formed, how do you go about it? Please take note of this point. Whenever you are done with the calculation and you know the limiting reactant, if they ask of the mass of the product, the mole of the product, we depend on the limiting reactant to do the calculation. Take note of this. It's very, very important. So with the calculation, the mass of the product formed, we depend on the limiting. So that is why we have N of O2 against N of CO2. We had the mole of this oxygen in the question to be 1.5. So when you divide, you get N of CO2 to be equal to 0.75 mole. We did this before coming to this slide. Alright, but in the question, we are not to determine the amount of CO2. We are to calculate the mass. So we can say that mass is equal to the moles times the molar mass. That is the molar mass of CO2. That is the product formed. So from this and the figure that was given, which is 1.5 here, we had the mole of CO2 to be 0.75 mole. So M is equal to 0.75 times the molar mass of CO2, which will give you 33 grams. So that is how we go about it when you are giving limiting reactant, when you want to determine in excess. There will be more questions on this. Thank you for watching.